Some pieces of infrastructure tell a story. At the Black Rock Lock, there are several to tell. The history of a project, the evolution of technology, and the passing of knowledge from one generation of engineers to the next.
So I worked on this back in the 90s. You don't realize how much knowledge you build up over 42 years. And I like teaching the young engineers all the new geotechnical engineering.
Gene has been the caretaker for this lock since the 1990s. Everything he has learned about the foundation, every crack in the wall, every little shift here, little shift there, he's taught me. Through my 7 years currently studying with him, I've learned the instrumentation, many different instruments that were installed here at Black Rock Lock.
One of the instruments Cedric has spent time learning about is called a piezometer, and there are a lot of them at the lock.
These instruments are telling us what's the difference between an okay little bit of movement, like the creaking of your floorboards, and a lot of movement, which would pose a risk.
There are several types of piezometers used throughout the Black Rock Lock. As technology advanced, so did the tools engineers used to monitor conditions beneath the surface.
So what we're looking at here is a pneumatic piezometer. And all it is it's a little tiny flap of rubber, and the rubber pushes down when we send the gas on top of the rubber, and it's pushing down the rubber, but underneath the wall, the water is pushing back up, and they're fighting each other, and you'll see this little ball move in a gauge, and it'll go up and down, and that's the water fighting the gas, and the gas fighting the water, and then eventually they're gonna come to a stalemate, just like a tug of war. One group of people on one side, one group of people on the other, eventually it's gonna stop, and when it stops, that's our reading. But that takes time, 5 to 10 minutes per instrument.
So they had to design something that worked a bit faster, which brings us to the present-day piezometer.
The vibrating wire instrument, right. All we have to do is we pop the cover open, and we're going to hook up the leads to the end of the instrument, and at the end of that instrument is a wire that vibrates. Now, the way to think of this is that if you had a big jar of honey, and we went and we put a spoon in the honey, and if you try to jiggle it, the spoon won't jiggle because the honey's too thick. And so the same thing happens with a wire in water. When the water's really shallow, the wire jiggles a lot. But when the water's really high, when the wire is in a lot of water, it jiggles slowly. And that's how we get a depth reading. And that's how this works. We can take a reading in under 5 minutes. So now we've cut the time from pneumatic piezometer readings in half.
While the technology changed over the years, the purpose remained the same, helping engineers understand what can't be seen beneath the ground and keeping everyone safe.
These instrument readings are critical to life safety. When we pull water out of the chamber, we need to continuously monitor all these instruments for any signs of tilting so that we can safely get our workers out from the inside of the chamber and to safety and refill the chamber before any sort of dangerous movement occurs.
The upgrades to the lock piezometers are taking place this summer, and when complete, will allow the lock to remain functioning at the high level it was designed to.
It's critical to understand what happened in the past so that you're not over-designing for the future.
But perhaps the greatest value is harder to measure: the transfer of decades of experience from one generation to the next.
Studying underneath somebody of that experience has been incredibly valuable to my becoming the senior geotechnical engineer for the lock.